Welcome to The Explainer. Today, we're taking a journey right to the absolute edge of physics as we know it. We're exploring the ultimate boundary in astrophysics, the event horizon. It's one of those wild concepts that completely challenges our very understanding of space, time, and, well, observation itself. So let's embark on this cosmic journey together and just jump right in.
Okay, let's dive into this. Right off the bat, we're faced with a massive, kind of haunting question. What actually happens when you cross the ultimate boundary in the universe? We aren't talking about crossing a state line or entering a new atmospheric layer. We're talking about a literal line drawn in the fabric of the cosmos itself. It's mysterious, it's grandiose, and for decades, it was purely theoretical. We really want to understand the exact mechanics of this crossing because it fundamentally breaks the rules of our everyday reality.
To grasp this, we first need to establish a very simple spatial concept. Think about a literal point of no return. It creates this beautifully stark contrast, right? On one side, you have the outside. Out here, no matter how strong the gravitational pull might be, you still have a fighting chance. With enough energy, you can theoretically still escape. But the absolute second you cross that boundary, escape goes from being incredibly difficult to being a physical impossibility. That absolute finality, that strict line between safety and an inescapable fate, is exactly what we call the event horizon. Let's ground ourselves with a strict definition before things get truly weird and relativistic. The event horizon is simply the boundary around a black hole beyond which nothing can escape, not even light. It sounds like a simple matter of fact, but it's the foundational rule for absolutely everything else we're going to discuss. Think about it. If light, the fastest thing in the universe, gets trapped, absolutely everything else does too. The door locks behind you, and there is no key. Now, what's really interesting about this slide is the inescapable, almost elegant mathematical logic of this trap. Let's walk through it step by step. Step 1. Right at the event horizon, the escape velocity, which is the speed you need to go to break free from the gravity, exactly equals the speed of light. Step 2. A core unbreakable rule of our universe is that nothing travels faster than light. So, step 3 becomes this undeniable conclusion. Since you cannot exceed the speed of light and you'd need to exceed the speed of light to leave, nothing escapes once it's inside. It is a flawless, unbreakable logical trap constructed by gravity itself.
But here's where we need to adjust our mental models a bit. The event horizon is not a physical surface. It's not a solid brick wall or some crust you crash into. It is completely invisible. It's merely a threshold. But man, what an eerie threshold it is. It marks the absolute limit of observable events. Once something passes this invisible line, it leaves our observable universe entirely. And perhaps the most tension-inducing fact here. Once you're inside, space and time warp so severely that all paths, no matter which direction you try to move, lead inward toward the singularity. There's no out anymore. Literally every direction is down.
Let's move to this and see how this builds into the mind-bending climax of our journey, the actual crossing. Because the event horizon warps reality so intensely, the experience of crossing it entirely depends on who is doing the looking. It is literally a tale of two perspectives, and it forces us to realize that time and space are just not the absolute fixed concepts we experience here on Earth. I really want to slow down here, because this comparison is profound. From your perspective, the one actually falling in, crossing the event horizon is surprisingly peaceful. Well, assuming you survive the initial tidal forces of spaghettification. But because the horizon itself isn't a physical surface, you cross it without noticing anything special. No alarms, no bumps, no flashing lights. You just glide right through. But to an outside observer watching from a safe distance, extreme time dilation takes over. The intense gravity warps the light and time around you. So to them, you never actually seem to cross. You appear to slow down, incredibly gradually, until your image practically freezes right near the edge, slowly fading away. One reality experiences a seamless fall, the other watches a frozen ghost. It is a stunning illusion created by extreme physics.
Now, lest you think this is all just theoretical chalkboard math, let's zoom back out to reality for a second. We have actual, real-life insight into this boundary. The Event Horizon Telescope project miraculously captured images of supermassive black holes, like the one in the M87 galaxy and our very own Sagittarius A star. And what we see in those images is a dark shadow. That shadow is the actual visual evidence of this point of no return. It's the visual manifestation of the boundary where light gets swallowed up and completely ceases to reach our telescopes. The math we just walked through is actively shaping the cosmos we observe right now.
And this brilliantly illustrates how expansive this concept really is. Let's broaden our understanding of astrophysics for a moment. This phenomenon isn't just limited to the crushing gravity of black holes. Yes, there's the black hole event horizon, but there's also the cosmological horizon. Because our universe is expanding, and doing so at an accelerating rate, There are regions of space moving away from us literally faster than the speed of light. That creates another type of horizon, a boundary beyond which light from those distant regions will never ever reach us. Two completely different cosmic mechanisms, both creating a strict limit to our reality. So, the crucial point is, why does all of this matter to us? Why should we care about invisible lines in deep space? Ultimately, the event horizon defines the actual architecture of reality. It defines the boundary of a black hole. It tells us exactly where the black hole essentially begins for the rest of the universe. But furthermore, it dictates the absolute boundaries of our scientific reach. Grasping this concept is absolutely vital because it teaches us that there are hard physical limits to human observation.
Which leaves us with this final, incredibly provocative thought. If the event horizon, whether around a black hole or at the edge of the expanding universe, defines the absolute limits of what we can ever observe, what lies beyond the observable? If all internal paths lead to the singularity, what actually happens to the information, the matter, the light that slips behind that curtain? It leaves us gazing up at the stars, fully aware that the universe is keeping secrets we are physically locked out from ever seeing. And honestly, that mystery is exactly what makes the study of astrophysics so endlessly captivating. Thank you for joining me on this explainer, and keep questioning the universe.